So I got some things in the mail, some circuit boards, and I figured I'd open them on camera. And we could open the box together. People love unboxing videos, evidently, on the internet. Now, just because I show something on camera here doesn't mean it's necessarily ready to be assembled and sold and so on. A lot of the things I do are experiments. I should say Ralph and I. My friend Ralph. Let's dump this stuff out. Now, if you don't know, I have a friend named Ralph Kornman. And Ralph Kornman likes to do software stuff. And I like to do hardware stuff. And so together we kind of like play around. It's I don't know, it's kind of fun. We make things. I'll do the hardware and Ralph will do the software. Okay, so Vectrex controller PCB. I got two different versions of this that I ordered. Now, if you don't know, I design circuit boards, and I order circuit boards, and then we sell them. Okay, believe it or not, this is actually kind of a basic thing. But believe it or not, someone asked online, "Hey, I wish I could buy Repro Vectrex controller PCBs." And I said, well, I left a post somewhere on Facebook, and it says, I don't know if it's really worth the time for anyone to do that. And so then all these people chimed in, and they says, yes, if you make them, I'll buy them, I'll buy them, I'll buy them. So I suppose I make them, and here they are. Really super simple. Hey Kelly, do you know where the that empty Vectrex controller is? Yeah. I wouldn't mind seeing if it fits. Because I'm literally opening this up for the first time, taking a look at it for the first time. And it'd be nice to see. Beautiful. Okay, so here is a Vectrex controller. And this would go something like that. Yes, it does fit. We have little tabs. There's little pins here and here. And the PCB snaps in. And then right here you can see the little pads. Ah, thank you, Kelly. Okay, there we go. So this is the original. This is the original PCB. And here's the Repro ones. So all these people asked for it. It's a simple job. There's nothing impressive about doing this board. But we'll see if people are still interested when it comes to buying them. Okay, so that's cool. I have a feeling it's so simple. I have a feeling that's a first try gonna work sort of thing. So that's cool. What's this say? Can cap. Ah, yes, I remember what this is. See, a while back, I made a little circuit board that replaced the big can capacitor, the multi-capacitor on like Space Invaders monitors and so on. Believe it or not, like there's this giant capacitor. It's like this big, okay? And here we go. It's about the size of a D-cell battery, okay? And in this capacitor, which is on like black and white monitors, there's 4 capacitors inside one can. Well, they no longer make capacitors like that anymore. Oh, okay, my wife is bringing stuff over. Here we go. Anyways, you see this big goofy capacitor on this monitor chassis? Well, they no longer make that capacitor. So, Stephen Gregory from Arcade Shop asked me if I could make boards. And I did make boards a while ago, and I didn't bother to look at the footprint. It was just a quick little half-ass fix for my own monitor. So, yeah, there's really nothing to it. Really basic little boards. See these 4 terminals and these 4 center pins would connect right to the harness. Because on the bottom, give me that harness real quick, would you? On the bottom of these, these chassis. It's called point-to-point soldering. For example, what a rat's nest. But this is how things were done back in the day when we were just coming out of vacuum tube stuff, you know. So I can see this little area right here. This is a capacitor, and there's 4 points for the capacitors, and there's 4 points for the ground or the mounting. So anyways, my plan is to give these to Stephen Gregory, and Stephen Gregory will populate these with the right capacitors, and then he will sell these on his website. Really basic, nothing to it. You see, when I order circuit boards, shipping is really expensive. And so I try to make a bunch of little cheap, easy crap. Cheap, easy things that I can fill the order with, because, well, you know, while you have something shipping, adding a little bit here and there is not so bad on the shipping cost. You already have to ship something after all. So what is this? G08 paddle boards. Here, can you grab the G08 deflection board? I think there's some over there. Okay. I know someone else did this already, but I'm going to do it again, only because I did a different part, and the other guy no longer makes them. Anyways, in the past, you may have seen this. This is a reproduction Sega G08 deflection board, okay? And I did this a year or two ago, and who was it? Someone made paddle boards. Now, these boards have areas right here and right here where you have paddle boards to stick out. And I did not reproduce those, but now I did. And the reason why, no, someone asked me a while ago, they says, Jason, why don't you just eliminate the paddle boards altogether? And that would be cool, but I can't. And the reason why I can't, well, you could, but the reason why I won't is because the harness is too short on the original G08 monitor. So it needs the paddle board installed just to clear. But yeah, so there's little paddle boards. Simple enough. That's going to go on there. It looks like this is a screw up. I think we got a measurement wrong. Hold on. Where's the original paddle board? Okay. No, that's the right. Okay. Okay, so here's the original paddle board. Here's my paddle board. See how wide that is? It's the same width as this paddle board, but I originally looked at this board and thought, well, hey, that's going to cover the yoke connector. But I guess it will actually just clear it. It'll be on this side. Does that make sense? So anyways, yeah, those should be good. Those should work. So, I don't know. I don't have all the parts for everything, but that's going to be something I'm going to assemble and sell for those that may need new paddle boards. Now, these paddle boards, these resistors would overheat when a transistor would fail. And they would burn holes in the paddle board. And so, oh, I already put it away. And so that's why I went with this. There has holes to let some of the heat pass through, and then it's shiny here to let some of the heat reflect back, to kind of prevent those burn marks you always see on these paddle boards. Maybe. We'll see. That's the idea, at least. It's probably boring to you guys. Oh, well, I think it's cool. Board A. I don't even know what this is.
Checks.
Oh, yeah. Yeah, there's a guy named DB Fishman. And he asked me a while ago, he says, hey, can you reproduce the boards in Chex Bubble Hockey? Because the boards are always bad. They're simple enough to just populate new boards. And I said, yeah, sure. So I did. And there was an error on... There's two boards. There's a scoreboard, then there's like another board. And there was an error. So I did these to fix the error. Yeah, I think it was... somewhere right around here, there's a trace that went where it shouldn't have gone. So I went ahead and redid those. So in order to remove the error. Cool. It's like Christmas for me right now because I've been wanting to see these for a while. I don't usually have lots of money, and believe it or not, it was well over $1,000. to order all these parts. I don't always have $1,000 free to order things. Multi-Centipede, ah yes. This is something I've already sold in the past, and people are still asking for them, so I guess I'll make more. It's a graphics hack. This is the Multi-Centipede. It plays 8 different variants of Centipede. It doesn't necessarily change the game, it changes the graphics around. For example, you can play Centipede with Pac-Man graphics, you can play Centipede with like Halloween graphics. You can do all kinds of different things, and there's 8 different variants. Well, really 7. We're including the original as well, so let's say 8, but it's really 7. But anyways, so yeah, there's different variants I did of this, and we ended up going with a AT-Tiny microcontroller to do the, mine went blank, the address shifting, address controller and all that. Because believe it or not, using a microcontroller was cheaper than using some TTL, you know, regular old 74 series or something like that. Anyways, I don't have all the parts for that, but I'll probably end up giving those to Arcade Shop or selling them again on my Facebook wall. And this is 6100 clones. I bought more of these. But, so anyways, you can actually buy these right now on arcadeshop.com. This is basically a standard Wells Gardner 6100 reproduction high voltage board. There's a couple differences. You don't have to use the jumpers anymore. It has different places, different areas where you can put more modern capacitors, easier to find capacitors and so on. What else? There's something else I did. Anyway, oh yeah, it has, I had this reproduced. I had a company in China reproduce these transformers. These are the current transformers that switch the transistor that makes the flyback switch. Anyway, so I had those reproduced, and they no longer make transformers of the old footprint. So this is running a more modern footprint to make that work. Anyways, you can buy those at Arcade Shop right now, along with the reproduction current transformers. Everyone calls them something T906 or whatever.
901.
901, there we go. But no one ever explains what they are. They're current transformers. Oh. So what is this? Vectrex new finished. 400. What is this?
I think those were Vectrex parts.
Oh yeah, okay, that's right. That's what it was.
I think.
Yep, that was exactly what it was. So anyways, this is more Vectrex multi-carts. If you don't know, I make Vectrex multi-carts for the Vectrex. And it is currently the largest EEPROM-based multi-cart in the market. It has the most games than any other cart ever made. That's not a smart cart. And so we're actually sitting around 2,900 sold, and this is 400 more of these right here. And these so anyways, pretty soon, like the next couple weeks, we're gonna go over the 3,000 mark. So there will be over 3,000 of these sold. Matter of fact, on the wall here I forget what number that was. Was that 1,000 or something? Or I don't remember.
It might have been.
I think 2,000 I gave away. But yeah, so those are Vectrex multi-carts, 400 of those. And it's funny because, hell, even around the 1,000 mark, I kept telling myself, well, that's it, no one's going to want any more. And I would stop making them, and then people would start messaging me, hey, when you going to make more? So I guess, I guess I'm stuck making those for a while. But, oh, this is box number 2. By the way, I get my stuff from jlcpcb.com. Look at that, free advertisement. But oh boy, let's try to adjust this camera a little bit. Oh, terrible heartburn. Guess that's part of getting old, man. It doesn't go away. I gotta remember to take those, what's that stuff I take, Kelly?
Prilosec.
Prilosec. Am I gonna be living on Prilosec till I'm dead now? Anyways, another box. Holy crap. Okay, move that out of the way. Ah, yes. These are reproduction Cinematronics CCPU boards. Now, I did this about a year ago, and it needed a couple jumpers. And so since I had a new order in, a new open order, I figured I'll go ahead and fix the errors on this board. So, oh, okay, there it is. I figured I would fix the errors on this board and order new ones. But yeah, this is the Cinematronics CCPU board. And, yeah, look at that, in purple.
Purple's my favorite color.
Yeah, sure, there is lots of ways on this board you could reduce parts, but I just kind of like it. I like that original look. How cool is that? You know, and this is the revision K. So this revision can do some of the newer things like color. Yes, there was color games like Boxing Bugs and so on. War of the Worlds. Yes, there was a color version of War of the Worlds. And it also has the JMI jumper to do some of the older games. So anyway, if you're going to clone one, Revision K was probably the board of choice, at least in my opinion. So anyways, yeah, so there was a couple errors that I had to do jumpers on the last revision to make it work. And I made it play Star Castle. A guy wanted to buy one, and he says he wanted Star Castle. So I just converted to Star Castle, and in the process of finding these errors, I found some other errors in the bank switching or address decoding section. And so I found out, okay, wait a minute. If I were to install Armor Attack, it wouldn't play Armor Attack because it wouldn't have switched it correctly. So evidently the old hacked version, hopefully this doesn't have any hacks. I think we got figured out. But the old version would have only played on 2716 games, and this should play on all. We'll see. Oh, this is a while back I made a actually this is really Ralph. Yeah, let me show that. Let's show that. This is an old version. Now, I did the PCB, but there's nothing to the PCB, right? You see how simple this PCB is, right? But Ralph did the work with the software in FPGA. This is an FPGA. This plugs into games like Gorf and so on that need to use that RAM card, and this can replace the RAM card, so you no longer use the RAM card. Well, in some other words, it replaces that RAM, which is that RAM's kind of goofy. It runs off like it's like cereal. Anyways, there really wasn't a good modern replacement for that RAM. So what Ralph did is he, basically made that RAM in FPGA with this FPGA, and I made a little board to basically stitch it to this, and so we know that's working theory, right? That'll work, right? Well, this is a whole different spin on the same thing. Turns out nowadays we have microcontrollers that are so fast we can actually use something else. See, and all this is, instead of actually producing this board, in the future, we're going to use this board. This is just a test here, but this runs on a microcontroller, and here's here's your level shifting and a regular microcontroller. Microcontrollers are so fast nowadays we can actually emulate video RAM with them. So, and these are cheaper components than this. So in the future, maybe we'll do this, maybe I'll lose interest. I don't know. I lose interest in things a lot. And I have so many unfinished projects. But yeah, so that's that. Put that away. I'm kind of excited to see all these toys to play with. I wish I had all the parts to assemble them all. This is another experiment. I made a prototype before that did not work. I found out the level translator did not work how I intended it to, how I thought it was going to work. Anyway, so this is an experiment. This, don't judge me, this is literally auto route. If you know what that means, you know what that means. But this was just as a quick test to see if I can get this to work. You see, this also runs off a microcontroller. Well, what this does is, it's called the Cinematronics Vector Generator. It's basically a vector generator, kind of like the Zector, and it plugs directly into a Cinematronics monitor. So you plug that right there. You have USB that comes out, or a Wi-Fi, and so on. You can make a multi-game out of this. You can make a what's it called? Test screens, like cross hatches and so on. You can make out of this. Now, but this is an experiment. This is a test, and what I'm testing is this is a 3.3 volt microcontroller. We have a 5 volt system, a 5 volt TTL monitor. Okay, now. Sometimes you can get 3.3 volts and talk to 5 volts directly. But you can't have 5 volt talk directly to a 3.3 volt chip unless it's 5 volt tolerant. Well, there is no talking from the monitor back to this. There's only talking from this to the monitor. So it's possible that your 3.3 volts might be a high enough threshold to make the 5 volt signal work. So that's what this is. There's no level translator in the middle. There's no way to talk and change the voltage that way. So what this is an experiment to see if we can make a vector generator talk directly to the monitor at 3.3 volts rather than 5 volts. That way I can drop a part. That drops one whole $1 off of the design of this. And so, I don't know, why not? And we had a problem with it last time. Oh, here, hold on. There we go. Here's the old one. There we go. Now see how it has this chip right here? You can see how these do not. So anyways, that's the test. See how that works. Here's another one. See, there's a guy by the name of Sean Kelly. He makes a really cool multi-cart. The Vectrex called the Sean Kelly multi-cart. He's been doing it for years. And I've done some PCB design work for him in the past. And, geez, if I could open this damn thing. Alright. Anyways, he asked me to make a wireless controller PCB. And this is really basic. It's literally an ESP32, a charge controller, voltage regulator, and so on, all built into a PCB that can fit inside the Vectrex controller. Where is that Vectrex controller, Kelly? I just had it in my hands.
It's back over there.
I'm curious if it fits again. Okay, let's see on camera here. Okay, it would go like that. Come on, I don't see it. Uh-oh. Oh no, there it goes. There it is. So it does fit. Anyway, so this would have a lithium polymer battery that'll go on the inside, and so on. And there it would go. Now, I posted this on Facebook, this PCB, or the design of it, and Clay Cowgill said that he thought it was a terrible idea that I use such a power-hungry microcontroller. And my argument was, well, hey, it's not so bad. I mean, the bigger the battery, the better it go. And I figured it would last like 30 hours on a single charge. But Clay suggested a different microcontroller that took like way less power, way less power. And instead of like 30 hours, we're talking if I were to use the microcontroller Clay suggested, instead of 30 hours, we're talking like 300 hours. So can you imagine a controller lasts 300? I don't even know if that makes sense in my head. But anyways, long story short, this is just another test. I'm going to make a wireless Vectrex controller, and we'll see how it works. In other words, it would hook up with Bluetooth or whatever and allow you to use it on... Oh, and I didn't explain this. In the future, we plan to make a dongle that plugs into the Vectrex that has its own wireless controller on it, so you can wirelessly talk to the Vectrex. So this is just part of it, you know. I know I mumble. I'm a mumbler. Now this is one thing that I was really excited. I wanted to see this in person. I think it's going to be cool. Yeah. Let me open it up. I wasn't sure how it would look in person. It was killing me. I wanted to see what this PCB looks like in person. I don't have an official name for this PCB yet, but I'll explain what it does if you hadn't figured out by the picture alone. Okay, this is a Tempest multi-game. So in other words, this has all kinds of oomph. There's a lot of power, a lot of CPU power behind this. And playing things like Tempest and so on, it's pretty easy for this microcontroller. But anyways, this would plug right into your Tempest PCB. Has pulse width modulation that would have the eyes would be controlled by the CPU. It has a rumble controller, MOSFET that controls that, a subwoofer out, a low pass circuit to create the subwoofer. And I should mention, Ralph Corman will be doing all the software, and this is just the hardware that I've done. So in other words, all I've done is I designed a circuit board, and I'll be assembling and selling these. But all the hard work was done by my friend Ralph Corman. Anyways, but yeah, this will be able to play a lot of games. A lot of games. But yeah, I'm so glad to see that in person now. Now, this is somewhat of an experiment. See, this is actually capable of putting out over 1 billion colors. There is no arcade game that supports 1 billion colors. But I wanted to have one hell of a massive color palette, maybe as bragging rights, so I can say I have the fastest DVG and the most colors. You know, bragging rights, I guess. Not necessary, I suppose, but the difference between the hardware is minuscule, so I might as well go big or go home. But this was sort of an experiment because this has 3 separate color DACs, and they're all running on their own 3 separate SPI channels. So, in other words, I can load, and I can make, or Ralph can make these SPI channels all spit out data at the same time, rather than, say, holding it and doing a sample and hold and so on, and waiting for all that data to go through one long path. I can cut that time by 3, divide that time by 3, and feed all 3 DACs at the same exact time, if that makes sense. So anyway, I can make this faster than there's another guy that makes a DVG on the market. This is way faster than his stuff. So the reason why you want these things to be as fast as possible is because, yes, it's possible to make cycle accurate emulation. And it's difficult, but it is possible. So in other words, this is capable of doing things the same, and giving the same output, the same time, same, what's a good word? I'm terrible at this. I'm not a good talker. Yes, the same timing outputs as the original PCB. For example, there's another thing out there called the USB DVG, and that has like an algorithm that figures out where the shortest jump routines are to draw different vectors and so on. And rather than doing that, this will draw something the exact same way as the original PCB. And that's important to me because, you know, things like the Zector ZVG, you could see if it was drawing too many things at once, the screen would start getting flickery a little bit. This should, in theory, be able to be cycle accurate and draw things the exact same way the original PCB does. But we'll see. This is just an experiment. We don't even know if this is going to work. I think it will, but we'll see. I don't know. But that goes into yet another extension of experiment. You got these guys. Ooh. Well, this is just a prototype once again, but Space Dual Black Widow Gravitar multi-game. Now, so and here's my bragging thing. 1.07 billion colors. But so anyways, this is yet another experiment. We'll see if it works. If it does, that's great. Using the exact same circuit on Tempest. Do you see this? The triple DAC setup for the colors. And yeah, and I know, yes, it could have been easier if I could have replaced all this, and half of this with one single chip. But if I'd have done that, it would have taken 3 times longer to feed it data. So that's why each single thing has its own special SPI channel. So anyways, if this works, if this works, that's great. And if it does, that means this will likely work too, because this is running on the same experiment. And Ralph, the guy that does the software, he has a lot on his plate right now. Like right now oh no, where's it? Oh, okay, there's more in the box. Okay, because the one thing I'm the most excited about, it hasn't been pulled out of the box yet. But okay, if I blabbered enough about this, I'm excited, guys. I'm excited. Let me get this out of the way. Now this is another experiment. We'll see if it works. Yeah. It's funny because someone was just telling me that they were making a JAMA adapter for Space Invaders. And so I was talking to him about how to do the colors. But anyways, this is yet another experiment. There's really nothing to it. It's really super simple. But what this does is it allows the ESP32-S3 microcontroller to plug directly into a Space Invaders or a Bally Midway 8080 cabinet. Now the beauty of this is it has the card here, so you can still plug in your original Space Invaders or whatever, Boot Hill, I don't know, 280 Zap, whatever game, okay? You can plug in your original sound control card into this board and produce sounds exactly the same way. So the only thing that would actually be emulated is the video itself, and you know the sounds will be perfect. In theory, we'll see. But yeah. Oh, and this has some goofy things. Rumble monitor. This has color output. If you want to do that stuff, and if you wanted to play around with putting a TV in your cabinet, which I don't suggest you do that, or if you want to play with it on the bench, whatever, it'll have audio and video outputs and so on. But yeah, so that is that. And USB, it can talk to the USB, or you can program to do updates with the USB on this. And that is that. I can't wait to play with that. Also, in case you didn't know what I'm talking about, right here, what is this? I don't know what this is. Okay, Laguna Racer. So this is the same PCB. This is Laguna Racer, which is also the exact same sound control board as Datsun 280 Zap. Okay? This would plug into this board, and you get original Laguna Racer sounds. Okay? But the video section is emulated. So anyways, there's a different kind of mode that this can go into, and it can go into a standalone mode. In theory, we'll see if it works. Now, let me show you the standalone mode. I'm going to go ahead and open this package. Ugh. Wow, these are pretty good. Okay, so this is a Repro sound control board. Now, there's really nothing special about this. It's literally just a blank board, and all it is an amplifier circuit, a subwoofer circuit with a little low pass circuit, volume, and that's it. It hooks to your sound controls. So when this board is plugged into this Space Invaders board, like that, one of the pins is grounded, and that lets it know that the custom board is put in. And when the custom board is put in, it will switch this into to a different mode. So in other words, once this is plugged in, it knows this is plugged in, and it will not try to treat it like an original soundboard. Instead, it will generate a PDM signal, and that is amplified through this, and the controls, rather than the sound control board talking to it, these controls are directly ported directly to the microcontroller, if that makes sense. So anyways, yeah, so now it's the first time I've been able to see that in my hand. That's what that would look like whenever it's done. Really cool. Okay, move this out of the way. Holy crap. Oh, is this boring to you guys? This kind of stuff I'm into, I don't know. I think there was another video I did a while back where I showed random things that I was opening up. I don't know if it's dumb or what, I don't know. But this is the board, this has to be, this box is what I'm excited about the most. Because it's done. We're literally ordering the final boards and soon they'll be for sale. Like, when I say soon they'll be for sale, maybe 2 weeks from now or less. Okay. This is the Asteroids PCBs, and we got like 190. What did I get? 125 of these. Yep. Anyway, so this is the Asteroids board, and the final errors were fixed. Hold on, my wife is trying to hand me a board. I'll grab it in a minute. But, so what this board does is, it plugs into any Asteroids cabinet, or Asteroids Deluxe cabinet. And it'll play Vectrex games. So you have your Vectrex controllers. Hold on, this is the old revision right here. Robert LaCour, this is yours. Anyways, you see I have a jumper here. So this was not the finished design, but anyway, so your Vectrex can plug into this. Okay, it has rumble motors, subwoofer out, and it plays. Oh geez, I'm not gonna tell you all the things it plays. How about that? We'll make a whole dedicated video of what this plays, but I will tell you this: it'll come out of the box with like 200 games, all legit vector games that will play on any Asteroids cabinet. Like 200 games, guys, and even then it can do even more because you can load more games on the SD card. And right now there's a group that I started on Facebook. It hasn't been as active as I wanted to, and that's my fault. But it's called the Asteroids Test Group. Okay, and so there's guys that are actively testing these games and making sure that there's no mess ups and whatever. And and you know, and what I wanted to say is, when this will be released, which is really soon, you'll be able to use 2 different versions, okay, of the firmware. Okay, the one version of the firmware is all the stuff that works. The other version of the firmware is all the stuff that works and the test games. Okay, so you can decide to join the test group. When this is open, when this is done, I'll have the test group opened. If anyone wants to join the test group and start testing things and so on, you can join that. And we have some like super high score guys and stuff in the test group and whatever. If you think you're a good player, that's great. If you just want to play around and you find something wrong, anyone of any degree can join the group. But I'll open that group sooner or later. But anyway, so yeah, that's what I'm going to do. I'm going to sell these. There's going to be the trimmed software with like, I don't know, 200 and some games or whatever. I don't know how many games for sure. A whole bunch of games, okay? And then there's going to be the open software that if you want to join the test group, you can test things. And if no one finds any problems with a certain game, it'll eventually cycle into the final firmware. But, yeah. So I guess that's it. I guess, you know what? I guess what I'm going to do now is probably turn the camera off and assemble one of these and make sure it's still good, because my life is kind of hanging on this, because I'm out of money. I need these to work. If these don't work, I'm screwed. I'll have to sell something just to make it. But yeah, if you notice, this has a jumper wire right here, and this goes to a 74LS04 hex inverter. And over here, this one will not need the jumper, and I made a mistake with that one. I ended up powering a 74LS04 with 5 volts. Well, that's a CMOS chip that can handle 3.3 volts, and it I should have made it do 3.3 volts. But so anyways, now it will do 3.3 volts, And the reason why I want to do 3.3 volts is because this is a microcontroller that runs off 3.3 volts and it's not 5 volt tolerant. So the way the original Asteroids board switches between first and second player on a cocktail is you have your controls over here, your controls on this side of the machine, right? Believe it or not, they're directly connected, the wires. So in other words, fire on this side of the cocktail, fire on this side of the cocktail is the same wire. The difference is the board can select if this set of controls gets a ground or if this set of controls gets a ground. And by doing that, it can save a lot of I/O on the circuit board. And so basically all this inverter does is it decides whether to give this control player 1 or player 2 a ground. But it switches it really fast. That way so it can detect a button press from this side or that side or this side or that side. Yeah, so I guess let me assemble this first one. And Kelly, should I do like a show-off video or should I make a whole different video?
I don't know. What do you think?
I think I will plant a seed and maybe show you like a few minutes, or a minute of some sort of gameplay, but I won't actually show you this until we're ready to sell it, which will be soon. Yeah, sorry. Real quick, I want to talk about someone else's project that I thought was pretty cool. This is a reproduction Black Widow / Gravitar PCB. Yes, Black Widow and Gravitar are two different games, but they both use the exact same PCB. And this was done by Douglas and Rotomotion on Clove. And they're currently selling these on Clove. I will put a link in the description. I think this is a really cool thing. Now, keep in mind, if you hadn't known already, that Douglas was responsible for the reproduction Omega Race PCBs. Yes, he made PCBs to replace the original Omega Race boards. And why would you want that? Well, the battery would leak on the original boards and they would destroy and corrode away a large section of the board, usually in this area. And often they're so far gone they really shouldn't be replaced. They really should be replaced. Anyway, so Douglas already has a good record of doing something like this, and now him and Rotomotion have teamed up and they have made reproduction boards. Now, this isn't what the original, this is not what the boards they're selling looks like. This is a prototype board. The prototype boards were black like this. And I think the ones that he is selling are green. I could be wrong. But anyways, we'll leave information in the description on how to get to Douglas and Rotomotion to purchase your own Gravitar / Black Widow board. Well, as you can see, we assembled this board and I put in a standard Space Invaders sound control board and it's working, buddy. Now pay no attention to this monitor. This monitor isn't the most healthiest. This is not the healthiest monitor, but there it is. It's playing Space Invaders. And that's running off the 8080 emulator board, or whatever you want to call it, Space Invaders main board replacement. And it's running off of the original sound and control board. So let's see what it would look like if you didn't have all that sound control board and you wanted to run the brand new one. Let's see what it would look like assembled. Okay, so here we have the board. Now this was just a test. This is the very first test to see if the board is working how we wanted it to. Now I already found some errors, some things I don't like about how the board is made. Number one, the footprint so I can mount this microcontroller is the pads are a little small and they're a little too far under the chip. Now this certain microcontroller has little edges on it that are shaped like this, so you can solder the pad and solder underneath it. So in other words, solder both pads together. Well, the pad that we're soldering to is underneath the microcontroller, so it's really difficult to solder. So I'm going to go into the footprint and make the footprint come out a little better. That way the soldering iron can touch both pads at the same time. So that's just someone's pre-made footprint that I just downloaded off the internet. So, there's also another issue found. The edge connector was too wide, and I didn't realize it until now, but the edge connector on the harness is narrower than your average edge connector. So I actually had to get a pair of cutters and snip off the edges of this just to make it so it can plug into the original harness. I wanted to show off at least how this looks. Now keep in mind, all this is just literally the first prototype. This could so change in so many different ways, but this is what I plan. Now this is the brand new board. If you notice, it doesn't have any parts on it because this works differently. This works completely different than the original board. Okay, there's a certain pin that grounds out another unused pin on the connector. Okay, this would plug in like this, and that would tell the microcontroller to go into a certain mode. And instead of talking to this, we use a PDM signal, which is then goes through a low pass filter and amplifier, and the data bus is connected directly to the controls. So in other words, it kills the whole data bus and everything, and uses those for control inputs. Now with this, the original soundboard, this needs specific frequencies and so on, and this has to generate those frequencies. For example, it'll get different frequencies and divide them up into sounds. For example, 480 hertz is one of the frequencies that this board needs, 60 hertz is one of the frequencies this board needs, and so on. And this has to generate those on the fly while it's running the code. But yeah, so anyways, not all this has been tested yet. I have high hopes. Kind of cool to see it work the first time. But yeah, I don't know, just an experiment. I guess I'm going to cut this video short here. We're going to call this a partial success. You know, maybe someday in the future we'll have this as a done deal. Tell me what you guys think about it in the comments. I guess that's it. This is my first video in about a year, guys. I've been real busy. It's been a crazy year for me. Anyways, so I hope to start doing videos again, and have a good one, guys.